If f and g are both differentiable functions and f equals the composition f composed g, which is defined by f of g of x, then f is differentiable and f prime is given by the product. F prime of x equals f prime of g of x times g prime of x. Now, to make the chain rule really, really simple, all you have to remember is this phrase. It is the derivative of the outside function, the derivative of the outside function times the derivative of the inside function. That's it. Derivative of outside times derivative of inside. I even wrote it there below. Derivative of outside times the derivative of the inside function. And now we can actually combine the power rule with the chain rule. So if n is any real number and f of x is differentiable, then the derivative of f of x to the nth power is going to be n times f of x to the n minus 1. Again, still following the same rules above. This is still the derivative of the outside times the derivative of the inside function. Okay, so let's go ahead and try it. All right. Number one, f of x equals the square root of x squared plus 1. Of course, we can't take the derivative in this form, so we're just going to rewrite it as x squared plus 1 to the 1/2. Okay, and now let's go ahead and apply the chain rule. So we're going to say f prime of x, and now we're going to take the derivative of the outside function, the derivative of the outside function, which includes this power, which means that 1/2 is coming down. So you'll get 1/2 times x squared plus 1. The inside stays the same. And since we took the derivative of the outside, you take 1 away from that power, which means you're going to get 1/2 times x squared plus 1 to the negative 1/2. Now, this is just the derivative of the outside. What we're going to do next is multiply it by the derivative of the inside function. So the derivative of the inside is going to be just 2x. Okay. Any questions on that so far? So all of that was the outside, and this was the derivative of the inside. And now we just combine the 2x and the 1/2 together. And this will give me f prime of x is equal to x times x squared plus 1 to the negative 1/2, which we can rewrite as x over x squared plus 1 to the positive 1/2. This is good, but you could also do one more rewrite as x over the square root of x squared plus 1. Okay, that's chain rule. That is the derivative of the outside times the derivative of the inside. Any questions on that?
No.
All right. Let's keep going at 10. Oh yeah, I didn't put the file in the chat. Terrible today. Unless you downloaded it from Canvas already, that's good too. Chain rule. Bam, there you go. Okay. All right, 2. y equals sine of x squared. I mean, this is definitely a composition function. It is a function made of two functions. So we're going to do the chain rule again. So we're going to say that y prime, and you're going to take the derivative of the outside function. So the outside function here is sine. What is the derivative of sine?
Cosine.
Cosine. So it's going to be cosine of x squared times, and now it gets multiplied by the derivative of the inside function, which is just 2x. Okay, put it together, and you give y prime equals 2x cosine x squared. There it is. All good? Not bad. Okay. All right, 3. Y equals sine squared of x. Now, to properly take the derivative of this, I'm going to rewrite it exponentially. So sine squared x is going to be rewritten as sine of x raised to the second power. And rewriting it this way, it's easier to see how the chain rule works on it. So for number 3, we get y prime, and now we do the derivative of the outside function, which means that 2 comes down. So you'll get 2 times the original function on the inside raised to the first power. There's the derivative of the outside. And then you're going to multiply it by the derivative of the inside. And again, what's the derivative of sine?
Cosine.
Cosine. Okay, there it is. There's the chain rule. The derivative's done. Now just combine our terms. I can rewrite this as y prime equals 2 sine x cosine of x. Now that's cool, but does anybody know the identity, the trig identity for 2 sine cosine x?
I don't have it in front of me. I'm going to guess 1 over tangent.
Oh, well, 1 over tangent is cotangent.
Sine 2x.
Whoa, who said that?
I don't know, man. They sound smart though.
So 2 sine x cosine x is the same as sine 2x. So 2 sine cosine is the double angle formula or identity for sine 2x. All right, not bad. Everybody good?
So when we putting these in like our homework or test, they'll have the it'll take both answers.
Yeah, it'll take both.
Okay.
But just I think if it's telling you to solve for x, sometimes putting it into a simpler format is a lot easier. But I think that comes later on. So that's why it's good to know identities, because I think later on in the class, we're going to be graphing functions like this, and you can keep it like this, or you can rewrite it like that. And if you rewrite it in this form, it's going to be a lot easier to solve for x. But either way, you'll get the answer. Okay. Okay, let's keep going. All right, 4. All right, now we know what we're doing. So here we have 3x plus 1 to the 4th. So the derivative f prime of x, somebody give me this derivative by chain rule.
Say it's 4
Okay,
times 3x plus 1 to the power of 3
good.
times 3.
There you go. Chain rules done, derivatives done. Now just combine those two terms. And our final answer is f prime of x equals 12 times 3x plus 1 cubed. That's it. That was nice, right?
And you don't want to distribute the 12.
The question is, can you distribute the 12?
Well, you would have to do the 3x plus 1 cube first, right?
Exactly.
Yeah, okay.
Which means that this is done because you don't want to create any extra work for yourself. So you would have to distribute all of this before you can even distribute that 12. Which I wouldn't do it because this is the simplified answer. That's as simplified as it gets. Okay. All right. That one was easy. Let's look at another one. 5 d over dx of 1 over x squared plus x plus 4 to the third. Well, we can take the derivative of this using quotient rule, or we can rewrite it as d over dx of x squared plus x plus 4 to the negative 3, which is going to be a lot easier than using quotient rule. Okay. And then with that being said, what is my chain rule derivative? What do I start with?
-3
Okay,
times x squared plus x plus 4 to the -4
good.
times 2x plus 1.
Very good. There it is. Derivative of outside times derivative of inside. And now just go ahead and multiply these two together. I'm not going to distribute the 3 just yet. I'm going to rewrite it as -3 times 2x plus 1 times x squared plus x plus 4 to the -4. So I'm just putting the 3 and the 2x plus 1 together. Don't distribute it just yet, or don't distribute it at all, because my final rewrite is going to be -3 times 2x plus 1 over x squared plus x plus 4 to the 4th. If you really want to distribute that 3, go ahead. It's just an extra step though. There's no need to do that. Okay, not bad. All good?
Andy.
Ah. Okay. All right, same thing with this one. Let's go ahead and rewrite it. We're going to first rewrite this as 1 over x squared plus x plus 1 to the 1/3. And then one more rewrite. X squared plus x plus 1 to the -1/3. Okay. We are now ready for the derivative again by chain rule. And what do I start with?
-1/3.
-1/3. The inside
one.
stays the same to the what power?
The power of for,
Well, you take one away from 1/3, from negative 1/3, right?
oh yeah, so that'd be wait, so negative 1/3 minus 1 would be negative 4/3.
There you go. Negative 4/3 times what? It's just the derivative of the inside. What you got?
Ah, right.
Anybody want to help him out?
2x plus 1.
2x plus 1. There we go. There's your chain rule derivative. Derivative of the outside times derivative of the inside. Finish it off. F prime x. I'll put these two together. Negative 1/3 times 2x plus 1 times x squared plus x plus 1 to the negative 4/3. And then we're going to get f prime of x as, and here's my final rewrite. I'll have negative, almost final, 2x plus 1 over 3 times x squared plus x plus 1 to the 4/3. Now that's definitely good, but you could also have, actually, let me do this. I'll write this out for a second. This is also the cube root of x squared plus x plus 1 to the 4th, which means it would become x squared plus x plus 1 times the cube root of x squared plus x plus 1. So that's a definite or, though.
Nice.
Yeah, right? Nice burp. If you want to distribute that negative, go on ahead. Okay. Any questions on that one?
No. Well, I'm not sure on the second to last step before you boxed it, where you moved it around, how you got just the negative on the.
So how I went from here to here?
Yeah.
Okay. Because, well,
Sorry.
no, that's a good question. So I could rewrite it as negative 1/3 times 2x plus 1 over x squared plus x plus 1 to the 4/3.
Right.
But since I have a fraction up here, that 3 just comes to the denominator.
Oh, okay. Duh. Okay, cool. Thank you.
Got it?
Yeah.
Cool. All right, what else? Okay. we come to our last two for chain rule. Oh my gosh, short day today, right? So go ahead and try 7 and 8 out. So when you do these chain rules, I'll give you a little hint for number 7. Number 7 is going to be a chain rule with a quotient rule. Chain with a quotient rule. So this is chain with quotient. And then number 8 is going to be a product with chain. So go ahead and take a couple of minutes to go ahead and try these ones out. And then maybe I'll finally put Ryan to work. Woo!
Oh, I still don't have my laptop, man. I can't write
What?
on anything.
What? Use your hands.
I hopefully I'm getting it back this Saturday.
Touch your screen.
Touch my screen.
Pull
Well,
out the whiteboard.
I can't. Touching my desktop does nothing.
Ugh.
Sorry, Brohim.
Never mind. You're fired, man.
All right, sounds good. Later.
All right. We'll let them figure out for a couple of minutes.
Yeah, do group work or something.
Yeah. In your non-groups.
Yeah. Yeah.
PJ breakout rooms.
Yeah, there was one student that was just adamant about not doing breakout rooms in Jerry's Cal 2.
Really?
Yeah. And he just because of that, he just didn't know what to do.
Well, I guess we're not doing breakout room, huh?
Oh, he just sent them to breakout rooms anyways.
Oh, did he?
Yeah.
Nice.
Yeah, that's funny.
It's December.
Yeah, I already started off wrong.
Where am I going to put it? I'll put it right here. Ooh la la.
Hacker,
Hacks.
math
Hacksaw.
hacker. Yeah.
Hacksaw. Okay. So you could have done the first way, which probably looked a lot easier than the second way, but I am showing you that you can change any quotient into a product rule to avoid the quotient rule in case it's too ugly. But in this case, product rule seemed to be a bit too ugly. All right. Any questions on that one?
On the product rule, I kind of lost you when you started using brackets there.
Oh, just for neatness. I use it to be fancy,
So you go
just to,
like, so you
to
go
show
from
the
a-
separation. But
Okay.
if you're wondering what happened from that step to that step, I was factoring. So from 9 and 18, what's my greatest common factor?
the greatest.
Yeah. Least
9.
common factor, greatest common
Oh.
factor, or from 9 and 18, what could I factor out?
A 9.
A 9, which I put right there. And then from x minus 2 to the 8th, x minus 2 to the 9th, how many of those could I take out?
Oh, I see. You take 8 out. Yeah.
You take 8 out. You always take out the smallest amount, right?
Yeah.
Which is going to make sense for the next one. 2x plus 1 to the negative 9, 2x plus 1 to the negative 10. Which one's the smallest power?
Negative 10.
Negative 10, which I factor out there. And remember, factoring is essentially dividing. So what we're doing is we're taking all of this from that term first. So 9 from 9 cancels. X minus 2 to the 8th from x minus 2 to the 8th cancels. And 2x plus 1 from the negative 10 from the negative 9 will leave you with 1 left over. In this case, we can call it extreme factoring, right?
And then you just decided to move the 18 to the other, like the negative 2.
Oh, so yeah. So now this greatest common factor is coming
Mhm.
from this one. So what's 9 factored from negative 18?
Negative 2.
There you go.
Yeah.
And then cancel, 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 cancel. And you're left with negative 2 times x minus 2.
So
Crazy, right? So it was factoring, but a little extreme. But either way, you see, we get the same answer. All right. Okay, let's try out the last one. There you go. There's F, there's G. F prime 5 times 2x plus 1 to the 4th times 2. G prime 4 times x cubed minus x plus 1 to the 3rd times 3x squared minus 1. Okay, clean this up. 10 times 2x plus 1 to the 4th and 4 times 3x squared minus 1 times x cubed minus x plus 1 to the third. Do not distribute that 4. All right. Product ruling. So f prime of x, f prime g, 10 times 2x plus 1 to the fourth times x cubed minus x plus 1 to the fourth plus g prime f, 4 times 3x squared minus 1 times x cubed minus x plus 1 to the third times 2x plus 1 to the fifth. Woof. All right. Derivatives done. Chain rules done. Product rules done. Algebra on from here on out. So let's play greatest common factor. And we'll start with 10 and 4. What could we take out?
Two.
2. And then we'll start with 2x plus 1 to the fourth, 2x plus 1 to the fifth. How many?
We got 4.
4. And then x cubed minus x plus 1 to the fourth, x cubed minus x plus 1 to the third. How many?
3.
3. Nothing else, right?
Yeah.
Bracket for neatness. And now factor this from the very first term. What am I going to be left with?
5.
5. And what else?
And x cubed minus x plus 1.
There you go. Plus, now factor all of this from all of that. What am I
2.
left with?
2.
2.
X squared minus 1.
And then,
And then 2x plus 1.
there you go. Extreme factoring.
Yay.
And now we just have to clean up everything in here. X cubed plus 3x squared minus 2x minus 1. Then let's just focus on that. 5x cubed minus 5x plus 5 plus 12x cubed plus 6x squared minus 6x. Oops. No. Minus 4x minus 2. And then again, combine like terms.
17x cubed.
17x cubed. All right, good. And
Plus
then
6x squared.
just 1, right?
Yeah. Minus 9x.
Minus
Plus 3.
9x. And then hey, and can't do anything else with that. So that means we bring this down to
You wrote squared for 17x.
oh, it's cubed, right?
Yeah.
Good catch. 2 times 2x plus 1 to the fourth. There we go. I can drop these since there's nothing else we can do. Boom, boom, and done. There you go, guys. That is a combo. That is a product rule and a chain rule combined. Okay. Any questions on these notes? Because we are done.
Shenanigans.